Hello everyone and welcome to this new tutorial on PLC programming and wiring. In this lesson, we will learn how to control a three-phase asynchronous induction motor with forward and reverse rotation also using the Siemens PLC. We will use this one, Logo 230 RCS PLC. You can see here on the screen. Yeah. Yes, first we will go a little bit to the schematics, the wiring diagram, and then we will do the basic or the main part PLC programming. So here you can see on the right side there are four buttons: emergency button, stop push button, and two green buttons that are start push buttons. We have also on the left side, if you see, we have two circuit breakers, two contactors, two thermal overload relays, and induction motor. So these are all the component we were gonna use it. We use two contactors. One, the motor will drive on the power direction, and the other contactor will drive the motor on the reverse direction. So before we move into the programming, let's go through the wiring schematics a little bit in detail so you should understand this thing. If you see the red push button, this is the emergency push button. It's wide normally closed with the input IN, if you see here. Here is a very important thing. If you see this single phase circuit breaker, we have two wires coming to the PLC to power or give electricity to the PLC. We have NLN. Basically here in the schematic it's in the opposite direction, but in the real PLC it will be LN first and neutral on the second. Neutral is all common with the inputs of the PLC. So you have to wire other side of your buttons to the L1. So L and the neutral is automatically common with the inputs. So here if you see I wire the push button with other side to L1 and to the input IN. Sam, here is a little bit mistake. It should be on 1, 2, not 3, 4, the wiring, because the 3, 4 is normally open and 1, 2 is normally closed. So here is a little bit mistake. You should wire it here 1, 2, normally open, not normally, normally close, not normally open. But 3, 4 is normally open. So it should be not here. This is wrong. So we should have on normally close 1, 2. Stop button, we have normally close 1, 2, it's wired to I2. One push button, it's wired to I3. And I3, it's for the forward direction. So it will, when I press this button, the motor will drive on the forward direction. And the last button, start button, it's wired to I5, if you see here. So when I press this button, the motor will drive on the reverse direction. Same here, we have two contactors. If I press this button, the first contactor forward direction will drive, and this thermal relay is also is an input to I4. And when I press the other button, so the motor will drive on the reverse side, and it will have motor thermal overrule relay as input to I6. So we have two contactors, one for the forward direction, one for the reverse direction, and then we have the induction motor. Two outputs put to this PLC. One is the contactor for the forward and Q2 for the reverse direction. So this is just a go through to the wiring, how we have wired this. Now let's jump to the programming. How can we make a PLC programming logic diagram for this one that we should upload to this PLC and it works. Now let's jump to my logo soft comfort software for the PLC. I will make a ladder logic diagram. So I will go to new, and we have function block diagrams, ladder diagrams, UDF, but I will use ladder logic diagram because we are using this one here. So this is my programming interface. On the left side, you can see my instructions, and these are all the menus. But first, because this program will include a start and stop buttons, emergency stop buttons, overload, protection relay, and contactors. We will basically build two rungs or networks. Network one for the forward directions. You can see here I will build basically two networks. Network one, this one for forward, and another program for this one in the reverse. And I will interlock this. To interlock this, that at the time only one network will running because the motor will be run only on forward direction or on the reverse direction. We cannot run on the both at the same time. So here we have two start buttons, one for the forward, one for the reverse. So this will be our inputs. Stop button will be also our outputs. Push button, emergency button will be our press and release for our emergency situation. This will be also our input. To overload thermal relay normally closed 95, 96 will be also our inputs. While these two contactors will be our outputs on Q1 and Q2. Q1 for the forward direction and Q2 for the reverse contactor or to drive our motor on the reverse direction. So let's start our first network. So I will take from the left side instruction make contact. So this will be basically my emergency button, emergency stop or emergency stop button. And in the simulation, it will be switch because it will be when we press it, so it will break the contact, and when released, it will go back to its normal position, normally closed, and it will conduct. So it will make the contact. Then I will take another one, and this one will be my I2, but this time, this in the comments, this will be my stop push button, and this one will be also my input I2. You can see here on the simulation because it will make the break because in the normal in the condition it will be normally closed. So when we press this button, it should break our contact. Then we have another one. We have connected stop or start push button to I3, and this will be our start push button for the forward. When I press this button, so it will basically uh, start or drive my motor in the forward direction, and it will be a momentary make contact because it will be wide or normally open. So when I press it, it should make a contact. So the difference between, if you see here on the stop, it should break. On the stop, it should be make contact. Then we have for the forward on the I4, I have wide uh, my thermal overload relay, or I can just write thermal relay forward. So in the simulation, it will also on the push button break because we will also wire this in normally close. Then we have an output or first contactor, and that will be uh, Q1 coil 1, which is connected to the Q1, and this will be my Q1 forward contactor. Okay, now I have connected all this in the series or in AND logic. So I will just wire all. Now to have a feedback that our contactor should be continuously energized when I press the release the button. So I have to do a holding circuit with my start button. Let me I will drag this a little bit more further. So I have space. Okay, so to have a holding circuit or we will make a or logic. So we will connect to I3 start push button a parallel branch and it will be our Q1. Now when I connect this one, so now this is my parallel or logic to the start push button. When I simulate this, so you can see here I will release my emergency stop button, press the button, so the contactor will energize. So our motor will run on the forward direction. Now stop the simulation. Now I have to make another one same for the reverse. So I take a contact here, emergency stop, then stop button, same. But this time I have connected, if you see here on the diagram, this one I have connected on the I5. You see here, uh, this one. So this is my push button for the reverse. Start reverse. And it will also my make contact because it's wired normally open. Same, we have a thermal relay here, and thermal relay is connected for the reverse is I6. So this will overload protection for my reverse contactor, or it will break the circuit when on the reverse direction. Same, it will break my. Now I have to go to my second output for the Q2, this contactor 2, and it will be my mm, sorry, contactor reverse Q2. But here I will also need a parallel branch for latching or holding my contactor. So I will take input and drag it here, place it here on the interface, and then I have to search my Q2 because this will parallel with my start push button for the reverse. So now we have two rungs, one for the forward, one for the reverse. So before going further, let's have discuss a very uh, important concept, interlocking. Let's simulate this first. When I simulate this first, when I press when I press the I3 start push button for the power direction, so the contactor for the power direction energize the motor running on the power direction. At the same time, when I press the push button start for the reverse, so the contactor for the reverse also energize and the motor will start running on the reverse direction. So here in a forward reverse motor circuit, we use two contactors Q1 and Q2. If both contactors energize at the same times, two phases are crossed. This causes a short circuit and can destroy our motor. To prevent this, we use interlocking. So now how we will use the interlocking, we will see here. Each rung has a normal closed contact from opposite direction. So I will stop the simulation here, and so how I will delete this here, this line, and I will put a QN. For this QN power contactor, I will make a normally close break contact here. So I put it this here and Q2, and same here for the reverse network. I will put Q1 here. So if Q1 is on in the forward direction, so the reverse rung will become open. So there will be no reverse direction and the Q2 will not energize. So let simulate this. So when I press this, Qn is energized on the power direction. Q2, when I press the I5, so I5, I cannot energize Q2. I have to stop it and then energize Q2. Now to make it more safer, so I can also do interlocking with my push buttons. So I delete this here, taking a contact, and I will put the push button for the reverse direction. Connect here, this here. Let me drag it so it should be clear. And I will delete also to put this line and to put interlocking for the reverse direction. And this will be my I3, which is the push button for the forward. Connect that it should power. So now I will simulate this. Okay, sorry, I go back to this is the, I will simulate from here. And now when I press the button start for the power direction, the motor is running on the powered contactor, so in the power direction. So when I press I5, the motor starts running on the reverse direction. So this is basically called the interlocking. When I stop it, both stops. same here, and you can see both. So this whole program is for the forward reverse direction for ladder logic diagram. So if I explain in the simple words, the interlocking, so if Qn or Q1 forward contactor energize, so the Q2 reverse contactor become open here with the start buttons in the forward and contactor. So this will, the motor will not running on the reverse direction. And same if I press the push button for the reverse, so this too, you can see here, for example, I press this button, so the motor is running on the reverse direction and this. But if I want to press this button, the start push button, so it will stop the reverse direction and go on the forward direction. Thank you very much for the watching. See you in next video. I will make a next video also how to upload this program to the PLS.